Hello, everybody. Today, our group will present a topic called PKI Lab. So, what is PKI? PKI stands for Public Key Infrastructure. And before we understand what PKI is, we must know what is a public key encryption. A public key encryption or a public key cryptography is a method of encrypting data with two different keys and making one of the keys the public key available for anyone to use. The other key is known as the private key. Data encrypted with the public key can only be decrypted with the private key, and data encrypted with the private key can only be decrypted with the public key. The public key encryption is also known as the asymmetric encryption. So what is PKI? PKI, as I mentioned, is public key infrastructure. It's a set of hardware, software, policy, and processes. Procedure required to create, manage, distribute, use, or store, and revoke digital certificate and public keys. As you can see in the diagram, PKI consists of three components: a certificate authority, a registration authority, and a certificate repository. And it is one of the most common form of internet encryption. So what is a certificate authority? It's the only trusted entity that issues with digital certificate and has its own key. The CA or certificate authority are what make the whole PKI system trustworthy. The CAs verify parties and issue certificate. Without the CA, the PKI simply wouldn't work because anybody can just issue certificate to themselves, saying and impersonating others. The registration authority is responsible for verifying the identity of the requesting digital certificate, and it can be its own CA or a third party. And the certificate repository is a public accessible location that generally store certificate and corresponding public keys which has been generated. It also consists of a certificate database and certificate policies. The X.509 certificate is a certificate that used widely accepted international X.509 public key infrastructure PKI standard to verify that public key belongs to the user computer and or service identity contained with the certificate. It includes a key information about the identity of the owner of the certificate and key, and the digital signature of the certificate authorities. So when we use the PKI is used when we want to provide a recovery key for an encrypted hard drive, or we want to secure the internal communication with the database servers, signing document, securing a local network, securing messages, or want to encrypt emails, or securing access to Internet of Things devices, and prevent the man-in-the-middle attack. So what is the man-in-the-middle attack? The PKI, the man-in-the-middle attack is when you deliver some message from A to B, and there a person C in the middle that want to edit, take, or want to copy that information. So we will go to the next presentation by Đức.
Hi, I will present how the PKI works. Each participant in the secure communication channel has two key, city public key and private key. Public key which you can tell to anyone who asks and is used to encode a message sent to you. Private key which you keep secret and used to decrypt the message when you receive it. Uh, we using a two key encryption system PKI secure the sensitive electronic information as it a pass and from between two parties and provide its party with a key to encrypt and decrypt the digital data. Uh, here is an overview illustration of how public key infrastructure work. Uh, there are four steps. The step one is the CA verify the community or server before issuing an SSL or TLS certificate. Step 2, the client verify the server via the CA chain of trust. The step 3, the public key is used to encrypt data. Step 4, the private key is used to decrypt data. I will talk about pop and com. Pops the has cost effectiveness will for some that's initial cost. This same sharing in the long run PKI physics algorithm much cheaper for organization. Government approved PKI option used by federal or organization. Their organization often consider PKI to be to their security goal. DeFi, health, and banking also rely on PKI for authentication and authorization. Con is fancy policy wrapping and assigning and training administrative user can be on going time consuming and costly. Managing PKI certificate can be challenging due to overheads required to important CIROS certificate as a side property, difficult for small organization to implement effectively without properly trained administrator. Next to demo PKI.
Okay, now we will move on to the demo section of the PKI, right? So in this demo, we are going to set up a basic PKI environment on our machine, deploy it on the browser, and see how it handles the man-in-the-middle attack, right? So the first thing we do is that we're gonna need to use OpenSSL, which is a protocol used for cryptographic stuff, right? So what we will do now is we are going to edit. We are going to edit the etc host file, and we are going to create our own website, right? So let's get the file first and move it to our work folder, right? So we have that file. And so by uncommenting that unique subject line, we will be able to like actually become a root CA to assign multiple certificates and stuff like that, right? And these folders are defined inside this OpenSSL file, this config file, and we're gonna need them so that our operation can load properly. So we have created 3 new folders and 2 files. These aren't that important overall, other than the fact that we need them so that the SSL file can run properly. Now we are going to become the root CA by following this long OpenSSL command. So as you can see from the presentation, there's this X509 standard along with some other things like RSA and SHA, right? So those are all cryptographic algorithms defined in the OpenSSL standard. So what we're doing now is that we are generating 2 files, the key file and this the CRT file, which is the certificate file, right, for us. So we're going to fill in some information, and this will make us like our own CA. Yeah, so that is task 1. We have become the root CA. You can check the content of the ca.cert and ca.key files if you want to by following these commands. They have the content of that. See that? Yep. So you can do similarly to the key file. So the next step to set up our PKI is to generate a signing request for the web server that we created at the beginning, right? The kang2021.com website. This is very easy. We're just gonna need one command. It's pretty long, but we're basically creating 2 new files, which is the key file and the CSR file, which is the certificate signing request for the web server. These subject and pass out commands are shortcuts so that we don't have to go through that filling in process again. This add extension command is it's not really needed. It's optional, but it's probably good to use. It basically allows you to use different domain names for your single website. It's not needed for this particular experiment, but it's good to know, right? So now we have created 2 new files, CSR and the key file for the server. And that's basically task 2. We now have the CSR so that we, as the root CA, can sign and verify the web server that we created before. So we move on to task 3. Okay, so this step is basically just for us to deal with the extension thing. Right. So uncomment that copy extension thing. Now we write this long OpenSSL command in order to sign that CSR file. All of these attributes can be looked up on Google for OpenSSL. If you're wondering, days 3650 means that how long this certificate is going to last, the expiration date, right? So this certificate is going to last for 10 years, basically. So after you do this, you have created a new file called server.crt, right? So you have basically signed the request from task 2, and now you're done with task 3, basically. And you can see that inside the request, there's also the alternative domain names, right? So that's just an extra, basically. Yep. See, we now have the server.crt file. So now that our server has had their certificate signed, we will now try to deploy the server onto an Apache server to demonstrate that we can actually access this website. So this command is to check the content of the server CRT file. So I've kind of skipped over the installation process, but it's rather easy to do. So you can look it up by yourself. But basically, we're going to need a Docker container to run the Apache server. Now, in this task, we're going to mainly set up so that the server can actually run. Okay. So basically, we're going to copy several files from our virtual machine into the Docker container through the volumes folder. Yep. And these HTML files are for our website, right? So that there's something to demonstrate. They already provided us with this, so we should use it. Okay. So we will run the Docker. So the first thing we need to do is copying all the files that we got before into the appropriate folders inside this container. There we go. So we're gonna need these for our website to have something to look at, right? Okay. So the next step is that we're gonna need to create a virtual host file, which is basically another configuration file that the Apache server can use to load our website. We'll create our own file for our own website. So we're going to copy all of these information from another file that's already available in the system to our own file and make certain adjustment. See? So the document root is where you keep the HTML files. The server name and server alias are for the domain names that we use. And the last two lines will contain the certificate and the key files for the website that we have created from like 2 tasks before. Okay. So now that we have this file, we can now begin to run the server. Okay, we have to enable this file first. Remember this. You have to enable this first. We will reload and restart the server. Okay, see, this line here, enter passphrase. If you're doing something wrong, you're not going to see the correct website name over here. You have to make sure that you run the commands correctly. If the website name pops up correctly, you're doing it right. So now that we have our website, let's see how Firefox responds. Okay, use HTTPS. This is the only way you can get a secure connection, all right? And you can see that Firefox doesn't accept it yet because we still haven't loaded our certificate so that Firefox can recognize it, all right? So what we're gonna do next is we are going to load it. Okay, access the preferences, privacy, view certificate, and import. Okay, remember to import ca.cert. That's the certificate that we use to let the browser recognize us. Trust to identify websites. So now you can clearly see that the certificate's loaded, right? You can see my name right there. So now, if we load the website again, you can see that we have gotten in. The browser has recognized us and connection is secure, right? Okay. So now that everything is set up, this is how we set up like a very, very simple PKI structure. So now let's see how this PKI thing is going to stop a man-in-the-middle attack. So basically what we're going to do is that we are going to impersonate GitHub and try to see how Firefox is going to defend against our impersonation. So basically what we are going to expect is that it's not going to work, right? So we have to go through two very simple steps. First, we're going to need to add another virtual host entry into our previous file, which is going to, we're going to keep the same configuration, but change it to GitHub. There we go, server name, yep. This is our impersonation, right? And we're going to go out. We're going to change our etc host file and add GitHub to it. Okay, so now, if you run it again, GitHub is not accepted because Firefox already registered a different certificate for the true GitHub, right? So our fake website does not have access to that real certificate. So the browser warns us that this is not a safe website to use because it cannot identify which one, if this one is actually the real one. So this is how it defends against the man-in-the-middle attack. We cannot impersonate GitHub because GitHub has its own identification that can be recognized by Firefox. And that's it. That's task 5, defending against a man-in-the-middle attack. Unfortunately, we ran out of time, so we couldn't really do task number 6. So it's unfortunate, but our demo is going to end here. So that's it for our presentation. Thank you for listening. Goodbye.